Hi. Good morning. My name is Ketejit. I'm from CSCD. So this concept video is about analysis of water chemistry. So analysis of water chemistry. Water chemistry analysis are carried out to identify and quantify the chemical components and properties of water samples. The type of sensitivity of the analysis depends on the purpose of analysis and the anticipated use of water. Chemical water analysis is carried out on water used in industrial processes, on water stream, on river and stream, on rainfall and on the sea. In all cases, the results of analysis provides the information that can be used to make decisions or to provide reassurance that conditions are as expected. The analytical parameters selected are chosen to be appropriate for the decision-making process or to establish acceptable normality. Water chemistry analysis is often the groundwork of studies of water quality, pollution, hydrology, and geothermal waters. Analytical methods routinely used to detect and measure all natural elements and their inorganic compounds and a very wide range of organic chemical species using methods such as gas chromatography and mass spectrometry. In water treatment, plants producing drinking water and in some industrial processes using products with a distinctive taste and odor, specialized organic methods may be used to detect smell at very low concentrations. Types of water: environmental water. Samples of water from natural environment are routinely taken and analyzed as part of predetermined monitoring program by regulatory authorities to ensure that the water remains unpolluted, or if polluted, that the levels of pollution are not increasing or are falling in line with an agreed remediation plan. An example of such a scheme is the harmonized monitoring scheme operated on all major river systems in UK. The parameters analyzed will be highly dependent on nature of local environment and the polluting sources in the area. In many cases, the parameters will reflect the national and local water quality standards determining the law or other regulations. Typical parameters for ensuring that unpolluted surface water remain within acceptable chemical standards include pH, major cations and anions, including ammonia, nitrite, phosphate, conductivity, phenol, chemical oxygen demand, COD, and BOD, biochemical oxygen demand. Drinking water supplies. Surface of groundwater abstracted for the supply of drinking water must be capable of meeting rigorous chemical standards following treatment. This requires a detailed knowledge of the water remaining entering the treatment plant. In addition to the normal suite of environmental chemical parameters, other parameters such as hardness, phenol, oil, and in some cases, a real-time organic profile of incoming water as the river deregulation scheme. Industrial water process. In industrial process, the control of quality of processed water can be critical to the quality of the end product. Water is often used as a carrier of reagents, and the loss of reagent to product must be continuously monitored to ensure that correct replacement rate. Parameters measured relate specifically to the process in use to any of expected contaminants that may arise as byproducts. This may include unwanted organic chemicals appearing in an inorganic chemical process through contamination with oils and greases from machinery. Monitoring the quality of wastewater discharged from industrial premises is a key factor in controlling and minimizing pollution of environment. In this application, monitoring schemes analyze for all possible contaminants arising within the process and in addition contaminants that may have particularly adverse impact on environment, such as cyanide and many organic species such as pesticides. In then nuclear industry, analysis focuses on specific isotopes or elements of interest, where the nuclear industry makes wastewater discharges to rivers which have drinking water abstraction on them, radioisotopes, in which could potentially be harmful for or those with long half lives such as tritium will form part of routine monitoring suite. Water chemistry analysis methods. Analytical methods routinely used can detect detect and measure natural elements and their inorganic compounds and extensive range of organic chemicals in species using techniques such as gas chromatography, mass spectrometry, ion chromatography, inclusively coupled plasma spectrophometry, and automated calorimetry. In water treatment plants, producing drinking water, and in some industrial processes using products with distinctive taste and odor, specialized organoleptic methods may be used to detect smell at low concentration. Water can be analyzed using different techniques. Calorimetric is used to find the concentration of a chemical element in a solution with the aid of a color reagent. It applies to both organic compounds and inorganic compounds. Titrometric. It is a technique where a solution of known concentration is used to determine the level of an unknown solution. Electronic devices, including digital meters, calorimeters, and photometers, are available as electronic devices for testing water. Common chemicals detected in water include chlorine, pH, temperature, iron, fluoride, turbidity, dissolved oxygen, trace metals, organics. So this is about the analysis of water chemistry. Thank you.